Suppose your customer says that he wants a header record at the beginning of the data that gives him the date of output in positions 1 through 10, with dashes in the date and a 4-digit year. He also wants the name of the person who output the batch in columns 51 through 70, and the header record padded with blanks to column 80, so it's the same size as the other output records. Unibase knows quite a bit about the status of output while the output program is executing, and Unibase shares its status knowledge via the conditional verbs that start with when. There are actually several of them. When start tells you when you're at the beginning of a job. When batch tells you when you're at the start of a new batch. When format or when program tells you when you're at a particular format number. There are other when verbs, some of which you'll learn about in a few more lessons. Let's go back to our program. The pace is going to pick up now. We'll cover several new verbs in this lesson. From the advanced processing, we'll choose D for file definitions, E for output, C for change, and change our program play. We want to output a date and the name of the person doing the output before we do any other output. We'll use the conditional verb when start right after our note and before our output. So we'll say when start, and let's go to a label that we call begin. And after this output, we'll put in the label begin, and we need our output statement. Output, Unibase has a control function called date4 that gives you a 4-digit year, month, month, day, day, y. And if we space once and put a dash, it will use the dash to separate the month from the day and the day from the year, just what your customer wanted. Alright, now we have to skip or fill with blanks through column 50. And we need a name starting in column 51. We'll use a variable since it's likely to be a different person's name each time and call it your name, and then we'll finish by skipping out to column 80. The when start conditional executes only if we're at the start of the program. If we're not at the start, Unibase will bypass execution of this go to begin statement. That looks good, but let's examine the flow more carefully. We tell Unibase to output using standard job play. Unibase initializes the output device stdent by blowing away the old student file, retrieves the first record in our first batch, and starts execution of the output program play. This statement asks if we've just started the program. That condition is true, so execution jumps to the begin label. Unibase puts out the date and the variable your name. Then what? Because we're at the end of the program, Unibase releases the record, retrieves the next record, starts execution of the program at the top again. But we haven't output the data in the first record. We completely missed it. We don't want to quit the program here. We want to send it back to the beginning of the program ourselves. How do we do that? With another go-to statement. This time we'll say go to the label top, and we'll put our label top right here, and let's clean this up by indenting it again. So now what happens? We output our date and name, we go back to the top and output the record rats. Now we continue on and write out the date and the name again. This is getting complicated. Do we need another label to jump around the begin code to get to the end of the program? We could, but Unibase has another verb, release. That means release the current record now and go get the next one, just as if I'm at the end of the program. So all we have to do is put release right after the first output statement. How are we doing now? We go get the second record, start back at the beginning of the program. This time it's not the start of the program, so we skip this go-to statement, do the output of record 2, and release the record and go get the next one. Seems like a winner to me. Let's test it. First we have to write the program out. F10W, then exit, F10X, and parse it. Play, field release, release. Oh, we got an error message. Undefined variable in line 11. Let's go edit the file. And when we come down to line 11, gee, I'll bet it's talking about the variable your name. Aid and a lot of other programming languages are fussy. If you're going to use a variable, you have to tell the program about it first. That's so the parser can check that you spell it the same way each time. It tries to help where it can. You wouldn't want the parser to assume that everything you type that it didn't recognize as a verb was automatically a variable, would you? That would be a disaster, especially the way some of us type. Alright, we need a declare statement. That's how you define variables, and you usually put it near the beginning of the program because Unibase wants to know about your variables before you use them. So after the note and before our first executable statement, we put in declare. And what are we declaring? The variable your name. And let's not forget our period. F10W, F10X, and this time it finished the parse. Let's go run it. Release, help, help, B, file input output, A, output via a standard job, play, and let's put a 0 and an asterisk. Isn't that a neat way to avoid the play test batch? Tell it no on selective use, release, and away it goes. Let's go look at our results. Help, E for system functions, F for OS access, field release, release, change to the temp directory, and type student. Looks like somebody from the Beetle Bailey comic strip output this job. 0. Date looks good though. Looks like you can have a program that parses and works, but it's still wrong. Hold that thought. It happens all the time. You need to know a few more verbs and programming techniques. Let's go back to our program, see where we went wrong, and what we can do to fix it. Type exit, release, help, D for file definitions, E for aid file output, C for change, play, field release, release. You need to know more about what the declare statement does. Besides identifying the variables you're going to use in your program, the declare statement sets initial values for them. Specifically, all variables are initialized to type numeric and given an initial value of 0, 14 of them. That gives you a 50-50 chance that your variable is initialized to the right type. We want your name to be alpha, not numeric. So how do we change it? By moving alphabetic data to it. Let's go to our begin routine. I can move 20 blanks to your name. That makes it an alpha variable, but not quite what our customer asked for. Instead, I can move a student to your name. That'll work. Let's try it. F10W, F10X. Parse it, play, release, and we're through. Help, help, file input, output, output with standard job, play, 0 asterisk, release, no, release, and we're through. Let's go see our results. Help, system functions, OS access, release, change to the temp directory, and type student. Okay, so we got a name in it this time. That's definitely better, but it's not quite what our customer wanted. He's expecting that we're going to have different people doing the output, and he wants to know who did it. So we need a way to ask the operator for that information. We'll do that in the next lesson.